Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2023. Question number 5 is on the topic on forces, mainly to do with springs and Hooke's law. But here it's to do with spring and the equation for elastic potential energy. Figure 8 shows a garden chair hanging from a spring. Which of the following describes the relationship between the weight acting on the spring and the extension of the spring? Now, according to Hooke's law, the weight or the force is proportional to the extension, which means that is the second option. When you increase the weight, the extension will also increase. 5.2. The person in figure 8 has a weight of 750 newtons. Now that's basically the force. The person's weight causes the spring to extend by 60 millimeters. That's the extension. Calculate the spring constant K. Use the physics equation sheet. The equation is force equals spring constant multiplied by the extension. Now the extension has to be in meters. This is in millimeters, so to convert 60 millimeters to meters, I would divide that by 1000. That gives me 0.060 meters. So 750 Newton is equal to the spring constant K multiplied by 0.060. So the spring constant is 750 divided by 0.060. That gives me 12,500 Newton per meter. So 12,500 is the spring constant. The manufacturer of the chair tests a new spring to see if it is suitable to hang the chair. The spring can store a maximum of 1,800 joules of elastic potential energy. So elastic potential energy before it becomes inelastically deformed. Describe what is meant by inelastically deformed. Inelastically deformed is when it changes shape when you remove the force. So an object that is inelastically deformed will not go back to its original shape when the force is removed. Question 5.4. Calculate the maximum extension of the spring before the spring becomes inelastically deformed. The spring constant is 225 Newton per meter. So use the physics equation sheet. The equation is elastic potential energy is half Ke squared. So 1,800 equals 0.5, which is actually the half, multiplied by the spring constant, which is 225 times E squared. So 1,800, rearranging it, divided by 0.5 times 225 will give me E squared, but I want the value of E, so I'm going to square root this to get the value of E. That gives me an extension of 4 meters. Question 5.4. Evaluate the suitability of the new spring to hang the chair. The maximum elastic potential energy is 1,800 joules. That's the energy. spring constant is 225, weight of the person is 750 Newton. Distance between the bottom of the chair and the ground is 30 centimeters. So if it extends above 30 centimeters, then the chair spring is not actually useful. So using this equation, force equals the spring constant multiplied by the extension. The force applied is 750 equals 225 times E. So E is 750 divided by 225, and that gives me 3.3 meters. So 3.3 meters. So the extension is far too much. Here it's 30 centimeters, so it has to be less than 0.3 meters. So the extension will be too great. So it's meaning the spring is not suitable for use in the chair. That brings us to the end of this question. Just out of curiosity, if you were to actually use a spring, the maximum force, so if I use this equation, F equals KE 225 times this extension of 0.3, the maximum force I can actually use is 67.5. That's probably for a child. So 750 Newton is way too much. You would need a spring which is at least, rather than 225, you would need at least 2250. That would bring it to, even then it's actually going to be much bigger. Anyway, that's the end of question number 5, and I will see you in the next question. Thank you.